Hello everyone, welcome to the Verification Lab. In this lecture series, we are going to learn SystemVerilog from scratch to the advanced level, covering both theory and practical implementation. This series is especially useful if you are targeting roles in design verification or working in a semiconductor industry. What is SystemVerilog? So, SystemVerilog is an IEEE standard language used for both hardware design as well as verification. What does IEEE standard mean here? IEEE is an organization which sets certain rules and regulation for this language that should be followed by all EDA vendors as well as industry and academia. So it is an extension of Verilog, which was introduced in the year 1985. Over time, Verilog alone was not sufficient for modern verification need. So System Verilog was developed and it was standardized in the year 2004. Today, the latest standard is IEEE 1800 2023, which continues to evolve with industry requirement. Why System Verilog was needed? As the chip became more complex, growing from thousands to millions of gate, engineer faces several challenges. Verilog did not support advanced verification feature. Writing reusable test bench was difficult. Here, reusable and modular verification environment where cannot be achieved by only Verilog. Reusable means the component used in verification can be used in other project. So reusability was not there in Verilog as well as modularity. Modularity means dividing the test bench into small module of desired functionality. So that were not present in Verilog. Engineer has to depend on multiple language like Vera and Specman E. This increases the complexity and reduces productivity. System Verilog solved this problem by introducing some new concept that are constrained randomization is one among them. It automate the test case generation that are diverse in nature, or you can say randomization was earlier present in Verilog, but it does not have constraint. So System Verilog bought this constraint randomization. Also object oriented programming that solves the problem for reusable and scalable test benches. And at last we can say it is a single unified language, removing the need of multiple tool or multiple languages. So four subset under one simulation kernel. So we don't need here different simulation kernel. So System Verilog have four subset and we will be discussing all of them. So first we are discussing about the design construct. So System Verilog has synthesizable RTL construct. Synthesizable means those construct can be translated into actual hardware. That means flip-flop and all the actual hardware required to draw a circuit. Then we have System Verilog for verification, used to build advanced test benches using class, inheritance, and polymorphism. Then we have assertion. Assertion are statements that used to check the property of the design. So in simple word, we can say used to check whether the design behaved correctly during simulation or not. At last, we have System Verilog functional coverage that is used to measure how much of the design has been tested. These are very broad concept. I have defined in a concise manner here. In the upcoming session, I will be discussing in detail, in depth of each and every concept. So together, this makes System Verilog a complete solution. How engineers use System Verilog? In a typical workflow, Engineer design the DOT using RTL construct, as I have mentioned, synthesizable subset. That means that can be translated into actual hardware. They create test benches using OOP-based concept, object-oriented based test benches that solves the problem of reusable and modular test bench. They add assertion to check bug early, and finally they use coverage to ensure all the scenarios are verified. And how the thing are achieved, I will be discussing in the upcoming session. This structured approach improve both quality as well as efficiency. Now let me discuss about the evolution timeline. So let's quickly understand how SystemVerilog evolved. So in the year 1985, Verilog was invented by Gateway Design Automation and standardized in the year 1995 with a number 1364. Then a new standard came and which have introduced some of the concept like multidimensional array, automatic variable. In the year 2002, SystemVerilog 3.0 was introduced. Now let us discuss some of the major milestones. In the year 2003, SystemVerilog 3.1 was introduced and it contained some of the advanced feature or subset we have discussed earlier. Among them are object oriented programming, CRV means constrained random verification, SVA that means system verilog assertion, and coverage. In the year 2004, System Verilog 3.1a refined by Accelera and it was donated to IEEE and IEEE give a number 1800. So this step officially unified the design and verification into one language. System Verilog is not built from scratch. It combines idea from multiple technology. For example, Superlog by Core Design and Automation, OpenVera and OVA by Synopsys, PSL or Sugar by IBM, Direct C, Synopsys, and Coverage API that was primarily by Accelera, and Tagged Union by BlueSpec. That is why it is so rich and feature complete. System Verilog assertion evolution. Assertion are the key strength of System Verilog. They allow you to define expected behavior, automatically check correctness during simulation, detect bug early in a design cycle. SVA is now an industry standard assertion language. It was derived from PSL, Sugar, Vera, and Specman E. Those are some contributor for the development of a complete assertion. So, rich temporal logic semantic. What does it mean? So, assertion has rich subset of temporal logic which can define the temporal, or we can say in simple word, the timing behavior or property of our design, and it can actually model the way that our design is working. And at last we can say industry standard assertion language today of due to its rich subset and rich temporal logic semantic. Now let us go through the modern IEEE revisions. So System Verilog has continuously improved over year. It started its first official standard in the year 2005 and slowly it moved, and we can say last was approved in the 2023 and released in the year 2024. Each version adds improvement as well as refinement. Why System Verilog is powerful? System Verilog stand out because it is a single unified language which support both RTL design and verification. Supports RTL to SOC verification with respect to verification, has built-in assertion as well as coverage, construct, and scalable for complex design. Complex designs means SOC designs. So we move to our summary section. To summarize, I can say System Verilog evolved from Verilog. It is an unified design and verification under IEEE 1800. It includes four powerful subsets working together. It forms the foundation for our modern design verification methodology, that is UVM. UVM stands for Universal Verification Methodology, that is intensively used as of now in the industry. So that is for today's session. In the next lecture, we will start System Verilog basics and slowly move toward the advanced verification concept. Thank you for watching the verification lab. Don't forget to like, subscribe, and share. Thank you.